very directly versus very indirectly. All right, so one of the concepts that we don't really cover here, or it's kind of talked about possibly in your Algebra 2 class, and I don't know that it's talked about anywhere else, is varying directly or varying inversely or indirectly. And the concept isn't all that different. If something varies directly, what that means is you have this relationship, y is equal to kx. So it's basically the slope-intercept form with the y-intercept being 0. And so if it tells you that two things vary directly, the k represents what's called a constant of variation. And so it just kind of says that as x increases, so does y. So that's why y varies directly with x. Right? And so if you're solving this, basically what you would do is you'd plug in the values. They'd say when x is 5, y is 12. Find what y is when x is 7. And so all you would do basically is you'd solve for your slope. And you solve it just like you would a slope-intercept, like a linear equation. Solve for the slope, that's your constant of variation, then plug it back into the equation. And so if that was the case, so if it said when x equals 5, y equals 12, find y when x equals 7. And so if this is your problem, the way that you solve it is you would simply take the given pieces, plug them into the x and y. So you'd say 12 is equal to k times 5. Divide by 5. And so there's your constant of variation, 12/5. And so then you just take that whole thing, plug it back into your original equation. So 12/5. And then substitute in your value of 7 for x. So just plug it back in. Does that see how that's familiar to the solving an equation using the slope-intercept form? So you get, here you just multiply it through 84/5 would be your answer. And so it's this relationship that holds true for y varying directly. And if y varies inversely, yeah, you can leave it 84/5. You could also remember, if it happens to be a fill-in, you can put it in decimal form too. Okay, the y varying indirectly or inversely has to do with as the relationship y is equal to k over x. So as x increases, y gets smaller. Right? So when you're looking at this relationship, it would be the exact same kind of thing. If it said when x equals 5 and y equals 12, if y varies indirectly or inversely with x, find y when x equals 7. You do the exact same thing. So you plug in your numbers to this equation, solve for k, and then plug that back in. So if we said 12 is equal to k over 5, multiply both sides by 5, so you get your constant of variation here is 60. And so when you plug in your equation to solve, you get y is equal to 60 divided by, and again if we use 7, and so that would give you your solution. Right? So if you looked at that relationship or those relationships, and anytime it says that it varies directly, it's basically a factor. The constant is a factor in the numerator. And when it says it varies inversely or indirectly, that the value that they're asking gets moved to the denominator. Okay? So use that. See if you can identify the expression that relates the information in problem 15. All right, so I'm going to go ahead and kind of start talking through. So if we just go straight down the list here, okay, and if you solve for y, you're able to see. So here, x varies because it's in the numerator directly, z varies directly, so we can eliminate this. And here, if we solve for y, we need to divide both sides by x cubed. So here, z varies directly, x cubed varies inversely, so that's not going to work either. Okay, we move to the next one. If we solve for y, we simply multiply both sides by a y. Right, so that cancels. And so here we get x cubed varies directly, z squared varies inversely. Is that what we were looking for? Yeah, so that's our answer, C. Now I'm going to just show you or demonstrate the remaining ones. Here, to solve for y, we would multiply by the reciprocal, x cubed over 5. Right, to get the y completely alone. Those all cancel. And so here the x cubed varies directly, z squared varies directly also. They're both in the numerator, so that's not going to work. And then here we'd multiply by the reciprocal, 2z squared over 5. So that, again, we get our y completely alone. So here, same thing, z squared and x cubed both in the numerator, so they vary directly. So that's not going to work. All right, be prepared. You probably will see one. This would be considered one of the latest problems you could have. This is like the hardest one that you could use for the variation. You're most likely going to see something more similar to the common one.